Hi, everybody. It's so wonderful to be here with you. And every time I come to one of these events, I'm absolutely blown away by the incredible scientific advancements of the community. But tonight, I want to talk to you about something a little bit different. I want to talk to you about the way we do science, and crucially, who gets to do it. And to do that, I'm going to tell you a little bit about my story. I grew up in a very poor working class household in North London, and I'd always been interested in science, and I loved space and dinosaurs, but I never believed that you could be a scientist as a job. And at school, I was told science is really hard. You have to be really smart to do science, so I didn't pursue it. And I left school having not done particularly well in my exams, and so I did what every little girl dreams of. I became a tube train driver on London Underground. I did that for 11 years, but I never really kind of gave up my interest in science. And there were a few people that I met over those years as I sort of pursued reading popular science books and watching documentaries that said, you know, you should take this more seriously, maybe pursue it. And so I did. I took evening classes and correspondence courses in basic high school maths and science to get myself back up to speed and to get those skills I needed. And then I went on to get a degree and then a PhD looking for life on Mars. I didn't find it, obviously, or you would have heard of me before. So after that, it was quite interesting. When I talked to people about the research I was doing, a lot of people I met in my life said, didn't they already find life on Mars like years ago? And I started to think about what difference it makes to individual people's lives when you're doing quite sort of abstract, far-removed science. And I really wanted to make an impact. So I started to think about what is the biggest problem that we're facing today? And for me, that was climate change. But how could I go from looking for aliens on another planet to looking at what's happening down here on Earth to the people who live here? And I know I'd already made one really big jump, going from driving a train to being a professional scientist, but how could I learn that new field? And that's when the perfect opportunity arose. I found the Schmidt Science Fellowship. Not only did they encourage you to pivot, they supported you through that really difficult time when you were in a brand new domain and didn't know what you were doing. And I was with a cohort of loads of people in exactly the same boat as me, and that made the whole thing a lot less scary. And so I pivoted. Instead of looking up to Mars, I was now using space satellites to look down at Earth's oceans to understand how they were changing and becoming more acidic as we put more CO2 into the atmosphere. But there was one big problem: our atmosphere, and chiefly clouds. Now, I know if you're from Southern California, you might not know what those are, but I'm from the UK, and let me tell you, there's a lot of clouds out there. In fact, if you look at satellites like the Sentinel-2 program that are designed to look at Earth's surfaces, our forests, our rivers, our deserts, our cities, they discard 60% of all imagery because of cloud cover. Now, these programs, they cost billions, and yet over half of the data is thrown away. And if you look at a satellite like the Landsat program, that goes back to the 1980s. So there's petabytes and petabytes of data that's been paid for by the taxpayer, but we're just not using it. So along with a couple of colleagues, we started to think, could one person's noise be another person's signal? Could we learn something from this discarded data? And clouds are incredibly important to climate change. Depending on their composition and their shape, they can have either warming or cooling effects, and we really don't understand them. In fact, they're the most critical unknown in our climate models. So we thought we could use AI and machine learning to troll back through this archive, and instead of leaving it gathering dust, make use of it, give some value back to the taxpayer. And we also wanted to think about the way we do this, the environment we do it in. We could have just done this like as a postdoc, and it was difficult to think about using open data and releasing it back out for free. How could we get investment to do this? And so what we decided to do was to start our own non-profit lab, Asterisk Labs. And we called it Asterisk, not only because it's a star to signify our space science background, but also because when you see an asterisk, it means there's something more to know. There's something underneath, behind there. And thanks to the Advanced Research and Invention Agency in the UK, they gave us the funding to do our project, Clouds Decoded, where we're now looking through this data to see how we can understand clouds better and do something about climate change. But we really wanted to go beyond that in our lab. We wanted to find other data sources that had unexpected uses. And we also really wanted to help people like me who wanted to get into science but maybe hadn't come from a traditional background. And that's why we're so proud of our collaboration with the Cloud Appreciation Society. Thank you. They're a fantastic organization. They have tens of thousands of members across the globe who just love looking at clouds. And they know clouds back to front. And we're working with them to come up with a new language for classifying cloud shapes from above instead of below. And they have a Cloud Spotter app where every day these members go out and take imagery of the clouds from the Earth's surface, and they tag them and they classify them, and they've got hundreds of thousands of them. And we're even working on functionality to get them to take imagery from below as the satellite passes overhead so that we can do multi-angle 3D reconstruction of these clouds from below. And we're really, really excited for that. And we want to make this something that's really mutual. A lot of citizen science projects can be a bit extractive, where people just do boring annotation tasks and don't really get to do the science. But we want to open up a pathway for people to learn about science, trust scientists more, become a scientist like I did. So, what I'm saying is, I think what we really need to do in order to solve the world's most pressing problems is work in more interdisciplinary teams. We want to see our lab expand and work with oceanographers, spatial epidemiologists, ecologists, social scientists, and then use AI as the connective tissue between these domains. And we want our model at Asterisk Labs to inspire others to think of their own models of doing science in a different way. Because if we open up science, if we open up pathways to different people becoming scientists, if we can find the silver lining in those cloudy pixels, then yes, science is hard, but together we can do something about it.